In the final days of World War II, German engineers built what many consider the most fearsome tank ever to roll onto a battlefield. The Panther. Sleek, deadly, technologically superior to almost anything the Allies could throw at it. But there was one enemy this magnificent machine couldn't defeat: itself. Today, we're diving into one of World War II's greatest engineering paradoxes. How did Nazi Germany create a tank so advanced, so powerful, that it terrified Allied crews, yet so fundamentally flawed that more Panthers were destroyed by their own mechanics than by enemy fire? This is the story of the Panther's final drive, a component so perfectly engineered it became the tank's death sentence. And by the end of this video, you'll understand why sometimes perfection is the enemy of survival. But here's what makes this mystery even more fascinating. German engineers knew about this fatal flaw. They had the data. They had the reports from the Eastern Front. So why did they keep building Panthers the exact same way? Right until the very end of the war. Stick around. The answer will surprise you. June 1941. Operation Barbarossa. German panzer divisions are rolling deep into Soviet territory, confident in their technological superiority. And then they meet the T-34. German tank commanders are horrified. The Soviet T-34 has sloped armor that deflects their shells, a powerful 76mm gun, and wide tracks that handle Russian mud like it's pavement. Meanwhile, German Panzer, IIs, and IVs are getting absolutely shredded. Panic reports flood back to Berlin. One German general writes, "The T-34 is the best tank in the world." Another states bluntly, "We need a new tank, now." So in November 1941, Hitler demands the impossible. Design and build a tank that can dominate the T-34, and he wants it in 6 months. What emerges from this crash program is remarkable. The VK-30.02, soon to be known as the Panther, or Panzerkampfwagen V. Let me paint you a picture of this machine. Weight: 45 tons of pure predator. Gun: a devastating 75mm KWK-42 that could punch through 120mm of armor at 1,000 meters. Armor-sloped frontal armor up to 80mm thick, nearly impenetrable from the front. Speed: a theoretical top speed of 46 km per hour. Engine: a massive 700 horsepower Maybach HL230. On paper, this thing is a masterpiece. Allied intelligence officers would later call it the most formidable tank of World War II. Sherman crews nicknamed it the Widowmaker. But here's where our story takes a dark turn. Hitler is obsessed with production numbers. He needs Panthers on the Eastern Front immediately, so he makes a fatal decision. Skip the testing phase. Normally, a new tank would undergo months, even years of field trials. Engineers would identify problems, make improvements, run more tests. It's unglamorous, but it's how you build reliable machines. The Panther gets 6 weeks. 6 weeks. In July 1943, 200 brand new Panthers are shipped directly to the front lines for Operation Citadel. The Battle of Kursk. This will be their baptism by fire. German commanders are excited. Finally, a weapon that can turn the tide. Within the first day of combat, 162 Panthers are out of action. But here's the thing. Most of them were never hit by enemy fire. They broke down. Engines seized. Transmissions shattered. Final drives, the crucial gears connecting the engine to the tracks, snapped like twigs. The most advanced tank in the world was destroying itself, and the worst part, German engineers immediately knew what was wrong. They filed reports, they sent urgent telegrams. They begged for production to stop until fixes could be implemented. But the Panthers kept rolling off the assembly line, unchanged. Month after month, right until the end of the war. So what was this fatal flaw? And why couldn't, or wouldn't, the Germans fix it? To understand that, we need to look at one specific component. A brilliant piece of engineering that became the Panther's Achilles heel, the final drive. Alright, let's get technical for a moment, but stay with me, because understanding this one component is the key to solving our entire mystery. Imagine you're riding a bicycle. Your legs are the engine. The chain connects your pedaling to the rear wheel. Simple, right? Now imagine that bicycle weighs 45 tons, needs to climb steep hills, cross muddy terrain, and occasionally sprint at 30 miles per hour. That chain connecting power to movement? That's your final drive. And it's one of the most stressed components in the entire vehicle. The Panther's final drive sits inside each of the drive sprockets. It's a reduction gear system that takes the engine's high-speed rotation and converts it into the low-speed, high-torque power needed to turn those massive tracks. Here's what made the German design so sophisticated. First, gear ratio. The Panther used a 4.22 to 1 reduction ratio through a series of helical gears. This was elegantly efficient. It meant more power reached the tracks with less energy lost to friction. Compare that to the Soviet T-34, which used simpler, more robust, straight-cut gears, or the American Sherman, which had a much more conservative drivetrain design altogether. The German engineers were obsessed with efficiency. Every component had to be optimized, sophisticated. Second, material science. The gears in the final drive were made from specially hardened steel alloys, machined to incredibly tight tolerances. We're talking about precision measured in hundredths of a millimeter. And third, this is where things get interesting. Size. Look at a Panther final drive next to a T-34's. The Panthers is smaller, significantly smaller. Why would German engineers make the final drive smaller when the tank is heavier and more powerful than its competitors? Two reasons, and this is where brilliant engineering becomes fatal flaw. Reason 1. Space constraints. The Panther's design prioritized a low profile and sloped armor for survivability. This meant less internal space. The final drive had to be compact to fit within the wheel assembly while maintaining the desired armor angles. So German engineers did what they do best. They over-engineered a solution. Smaller gears, tighter spacing, more sophisticated materials, all to pack maximum power transmission into minimum space. But here's the problem with over-engineering. Reason 2. The manufacturing reality of 1943 to 1945 Germany. By 1943, Allied bombing campaigns are devastating German industrial capacity. Precision tool manufacturers are being destroyed. The supply of high-quality steel alloys is dwindling. Skilled machinists are dying on the Eastern Front. Yet Hitler demands more Panthers. 6,000 Panthers will be built during the war, and production keeps accelerating even as quality control collapses. So now you have a component that requires perfect materials, perfect machining, and perfect assembly being built in factories that are bombed every week, with substitute materials, by inexperienced workers, under impossible deadlines. Those precision gears. They start coming out with microscopic flaws, impurities in the steel, tolerances that are off by just a fraction, heat treatment that's inconsistent. And remember, this final drive is transmitting 700 horsepower through a 45-ton vehicle. Every time that Panther accelerates, climbs a hill, or turns sharply, those tiny gears are enduring enormous stress. A microscopic flaw becomes a crack. The crack propagates under stress, and suddenly snap. The gear teeth shear off. The final drive seizes, and that 45-ton Predator becomes 45 tons of immobile metal. But here's what makes this truly tragic. German engineers documented this failure mode in August 1943, just 1 month after Kursk. They knew exactly what was wrong. They proposed several fixes. Make the final drive larger. Use simpler, more forgiving gear designs. Extend the testing period for quality control. Reduce the power output slightly to decrease stress. Every single recommendation was ignored. Why? Why would Germany keep building Panthers with a component they knew would fail? The answer involves politics, desperation, and one of the strangest decisions in military history. Let me read you an excerpt from a field report dated September 15, 1943. This was written by Major Heinrich Ernst Eberbach, commander of the 51st Panzer Battalion on the Eastern Front. Just 2 months after the disaster at Kursk, of the 48 Panthers assigned to my battalion, only 11 are currently operational. 23 have suffered catastrophic final drive failures. 8 have transmission damage. The remaining 6 have engine problems. We have not engaged the enemy in 4 days. The Soviets do not need to destroy us. We are destroying ourselves. This wasn't an isolated complaint. It was one of hundreds of similar reports flooding back to the German High Command throughout late 1943 and early 1944. Tank crews, field commanders, maintenance officers all sending the same desperate message. The Panther is mechanically unreliable, and the final drive is the primary culprit. Here's another one, this time from a maintenance depot commander in France. April 1944, just weeks before D-Day. Final drive lifespan averages 150 kilometers before failure. This is unacceptable. Soviet T-34s achieve 3,000 kilometers. American Shermans exceed 4,000. We are losing the war not to superior enemy tanks, but to our own engineering hubris. 150 kilometers. That's roughly 93 miles. Imagine buying a car that breaks down after driving from New York to Philadelphia. That's the Panther's final drive reliability in 19. The engineering teams at MAN, the primary manufacturer of Panthers, were well aware of these problems. In fact, they had been warning about them since the prototype stage. A company memo from December 1942, 6 months before the first Panthers even saw combat, explicitly states, current final drive design is inadequate for the vehicle's weight and power output. Recommend enlarging the unit by 30% and increasing gear tooth width. This will delay production by approximately 3 months. 3 months, that's all it would have taken to potentially solve the problem before a single Panther rolled into battle. But Hitler personally rejected the delay. He needed Panthers at Kursk. He needed the production numbers for propaganda. He needed to prove to his generals and to the German people that the Wehrmacht still had technological superiority. So what happened to those engineering recommendations? They went into a bureaucratic black hole. The German military-industrial complex by 1943 was a nightmare of competing interests and political infighting. You had the Army Weapons Office, the Ministry of Armaments and War Production under Albert Speer, Hitler's personal staff, and the SS all fighting for control over tank production. Each group had different priorities. Speer wanted impressive production statistics to show Hitler. The generals wanted reliable tanks that wouldn't break down. The SS wanted resources diverted to their own pet projects, and Hitler wanted miracles. He wanted Panthers that were invincible, produced quickly, and he refused to accept that you couldn't have both. There's a fascinating meeting recorded in the minutes of the Panzer Commission from November 1943. Engineers from MAN presented a comprehensive redesign of the final drive. Larger gears, better metallurgy, improved lubrication systems. The projected result, a failure rate reduced by 70%. The cost, a temporary reduction in monthly Panther production from 250 units to 180 units for 4 months, while retooling occurred. The proposal was rejected within 48 hours. Not because it was technically unsound, everyone agreed it would work. It was rejected because Albert Speer had just promised Hitler that Panther production would increase to 300 units per month by spring 1944, admitting they needed to slow down. Production to fix a fundamental design flaw would mean admitting failure, and in Nazi Germany in 1943, admitting failure could be fatal. So instead, they did something remarkably cynical. They implemented minor fixes, band-aids on a severed artery, better lubricants, slightly modified gear profiles, training manuals that instructed drivers to be gentle with acceleration and turning. They even reduced the recommended top speed from 46 km per hour to 40 km per hour in official doctrine, hoping that would reduce stress on the drivetrain. None of it worked. The fundamental problem remained. You cannot fix a design flaw that requires the component to be 30% larger by making the existing component slightly better. It's like trying to fix a bridge that's rated for 10 tons by painting it really well before driving a 20-ton truck across. By late 1944, the situation had become darkly comedic. Panther crews were developing their own field modifications. Some units discovered that if you removed certain limiters on the governor, you could reduce the torque transmitted to the final drive, which extended its lifespan at the cost of making the tank significantly slower. Other crews learned to drive exclusively in lower gears to reduce stress, which increased fuel consumption to absurd levels. Some commanders simply ordered their Panthers transported by rail as close to the front as possible to preserve the final drives for actual combat. The German army was performing logistical gymnastics to work around a problem that could have been solved with a 3-month production delay in early 1943. And here's the cruelest irony of all. By 1945, with Germany clearly losing the war, some factories finally began implementing the original redesigned Reckitten's Panthers. Built in the last 3 months of the war had significantly improved final drives. Field reports from February and March 1945 show failure rates dropping dramatically. But by then, Germany had no fuel, no spare parts, and no territory left to defend. The fixed Panthers arrived just in time to be abandoned or destroyed by their own crews during the retreat. So why did they ignore the reports? Why did they keep building flawed tanks for 2 full years when they knew exactly how to fix the problem? It wasn't stupidity. It wasn't even necessarily malice. It was something more mundane and more terrifying. Bureaucratic inertia combined with political pressure and a refusal to accept uncomfortable truths. The reports weren't ignored because no one read them. They were ignored because acting on them would require powerful people to admit they'd made a mistake. And in Nazi Germany, admitting mistakes wasn't just career-ending. It could be like, let me tell you about Oberfeldwebel Karl Braumann. He was a Panther commander in the 2nd SS Panzer Division Das Reich, and he kept a personal diary throughout 1944. His entries provide a ground-level view of what it was actually like to operate these machines. June 8, 1944, 2 days after D-Day. Received our new Panther yesterday. The crew is excited finally. A tank that can match anything the Americans throw at us. We've named her Gertrude after my wife. Drove 12 kilometers to our staging position. Final drive on the right side is already making concerning noises. Reported to maintenance, they shrugged. June 12, Gertrude's right final drive failed completely during morning exercises. We hadn't even seen combat yet. Replacement will take 3 days. The Americans are 40 kilometers away and advancing. We sit here, useless. June 15th, new final drive installed. Made it 8 kilometers before the left side failed. I am beginning to hate this beautiful, useless machine. This wasn't just Brahman's experience. This was the reality for thousands of Panther crews across every front. They were given what was supposed to be the finest tank in the world, and it kept betraying them in the worst possible moments. Talk to any surviving Panther veteran and, yes, some are still alive today and they'll tell you stories that sound almost identical. The Panther was magnificent when it worked. The gun was accurate and devastating. The armor could shrug off hits that would destroy a Sherman. The optics were superb. But none of that mattered when you were stranded 20 kilometers behind enemy lines because a gear the size of your fist had disintegrated. There's a recorded interview with Unteroffizier Hans Becker, a Panther driver, conducted in the 1980s. He describes the psychological toll of driving a Panther. Every time you accelerated, every time you turned, you were listening. Always listening, waiting for that grinding sound that meant you were about to become a pillbox. We were more afraid of our own mechanics than we were of enemy tanks. The crews developed an almost superstitious relationship with their Panthers. Some drivers refused to use full throttle under any circumstances, believing that gentle driving would appease the mechanical gods. Others performed elaborate pre-mission rituals checking and rechecking the final drive oil. Even though everyone knew that oil level had nothing to do with gear tooth failure, it gave them the illusion of control. Maintenance crews had it even worse. Replacing a final drive wasn't like changing a tire. It required lifting the entire tank, removing the track, disassembling the wheel assembly, and then carefully extracting the failed unit. The whole process took a skilled crew about 8 hours, assuming you had a replacement part available, which by 1944, you often didn't. There's a particularly tragic report from Normandy. July 1944, a Panther battalion of 76 tanks was ordered to counterattack American positions near Cannes before the attack even began. 31 Panthers experienced mechanical failures during the 15-kilometer approach march. Of the 45 that made it to the battlefield, 12 more broke down during combat. Only 33 Panthers actually engaged the enemy, and of those, American tank destroyers knocked out 18. By the end of the day, the battalion had 9 operational Panthers left, 9 out of 76. The Americans studied the abandoned Panthers afterward and were baffled. Many of them showed no battle damage whatsoever. They'd simply stopped working. One American after-action report noted, "Enemy appears to be fielding tanks of exceptional design but catastrophic reliability. Recommend we continue current engagement strategies and allow enemy mechanical failures to supplement our tactical efforts. In other words, just wait. The Panthers will destroy themselves." But here's what makes the crew's experience even more heartbreaking. They knew their tank was fundamentally flawed, but they also knew it was the only thing standing between them and Soviet T-34s or American Shermans that outnumbered them 5-1 or more. When your Panther was working, you had a chance. When it wasn't, you were utterly helpless. Former Panzer officer Otto Carius, who wrote extensively about his experiences, put it this way: the Panther was like a thoroughbred racehorse with a broken leg. Magnificent to look at, capable of incredible performance, but requiring constant care and still likely to collapse at any moment. And unlike a horse, we couldn't shoot it and get a new one. We had to coax it forward, kilometer by painful kilometer, praying it would last until the next depot. The psychological impact was profound. Tank crews are supposed to trust their machine. It's your armor, your weapon, your mobility, your life. But Panther crews learned quickly that they couldn't trust theirs. Every mission was a gamble. Would this be the one where the final drive gave out? Would you make it back to friendly lines? Or would you be forced to abandon your tank in enemy territory? And abandoning a Panther was its own nightmare. German doctrine required crews to destroy their own tanks if they couldn't be recovered. You'd set thermite charges, watch your Panther burn, and then march back through enemy territory on foot. Many crews never made it back. They'd survived months of combat only to be captured or killed because their tank broke down at the worst possible moment. There's a photograph from the Battle of the Bulge, December 1944. It shows a Panther sitting perfectly intact in the middle of a Belgian road. No shell holes, no visible damage, just sitting there. The caption, written by an American intelligence officer, reads, "Abandoned due to mechanical failure. Tracks intact, gun operational, final drive failed. Crew departed on foot." This appears to be the German Army's most common method of losing tanks. By early 1945, Panther crews had developed a gallows humor about their situation. One crew painted on their tank, "Fart nicht, Sheet nicht, aber sieht gut aus, doesn't drive, doesn't shoot, but looks good." Another crew named their Panther tow truck required before they'd even taken it into combat for the first time. The most experienced crews learned to read their Panthers like doctors reading symptoms. A certain vibration meant the final drive had maybe 50 kilometers left. A particular whining sound meant you should start looking for a place to break down that was defensible. The smell of overheating gear oil gave you maybe 10 minutes warning. These men became experts in managing decline, in extracting maximum performance from a machine they knew was failing. But no amount of skill or experience could overcome the fundamental flaw. The final drive was a mechanical time bomb, and every Panther crew knew it. They climbed into their tanks each morning knowing that today might be the day the gears failed, and there was absolutely nothing they could do about it except drive carefully, pray quietly, and hope they'd be near friendly lines when the inevitable happened. That's what it was like to live with the perfect machine that destroyed itself. Not from enemy action, but from its own impossible contradictions. So here we are, nearly 80 years later, and the Panther remains one of the most debated tanks in military history. Walk into any forum where military historians and tank enthusiasts gather, and you'll find people still arguing. Was the Panther a masterpiece or a failure? The answer, frustratingly, is both. From a pure engineering standpoint, the Panther represented the pinnacle of German design philosophy. Every component was optimized, every system was sophisticated. On paper, and in those rare moments when everything worked perfectly, it was arguably the best tank of World War II. Allied tankers who faced Panthers and survived universally described them with a mixture of fear and respect. But engineering doesn't exist in a vacuum. And this is where the Panther's story becomes a cautionary tale that extends far beyond World War II tank design. The Panther failed because it was designed for a war. Germany wasn't fighting. It was a precision instrument built for a world of unlimited resources, skilled craftsmen, and time for proper maintenance. But Germany in 1943-45 had none of those things. They had bombing raids, material shortages, and conscripted labor. They needed tanks that could be built quickly, maintained by inexperienced crews, and operated under brutal conditions with minimal support. The Soviets understood this. The T-34 was crude by German standards. Its optics were inferior. Its gun, until late war versions, was less powerful. Its armor wasn't as well developed, but it was simple. It could be built in factories that were barely more than sheds. It could be maintained by crews with minimal training. It could run on low-grade fuel, and crucially, its final drive and transmission were over-engineered for durability, not efficiency. The T-34's final drive was bigger and heavier than it theoretically needed to be. German engineers probably looked at it and thought, how wasteful, how inelegant. But you know what the T-34's final drive did? It lasted. It worked. It kept Soviet tanks moving forward while Panthers sat broken by the roadside. This is a fundamental lesson of the Panther. Perfect is the enemy of good enough. And in war, good enough wins. But there's a deeper lesson here, one that applies far beyond military history. The Panther failed because the people in charge refused to accept feedback that contradicted their goals. Engineers said, this needs to be fixed. Leadership said, we need production numbers. Those two imperatives were incompatible, and leadership chose to pretend they weren't. This pattern repeats throughout history. Companies that ignore quality control to meet quarterly targets. Governments that suppress data that contradicts their policies. Any organization that prioritizes appearances over reality. The Panther is what happens when you value the idea of perfection more than you value things that actually work. And here's the tragic irony. If Germany had accepted a temporary slowdown in production in late 1943 to fix the final drive, they would have ended up with more operational Panthers in the field by mid-1944 because tanks that don't break down are infinitely more valuable than tanks that never leave the repair depot. There's a calculation that military historians sometimes make. Of the roughly 6,000 Panthers built during the war, probably fewer than 2,000 were destroyed by direct enemy action. The rest, mechanical failures, most commonly final drive failures, that forced crews to abandon them. Imagine if even half of those had been operational. The war would still have ended the same way. Germany's strategic situation was hopeless by 1944. But the tactical situation on both fronts would have been dramatically different. The Americans and British knew they were facing a flawed weapon. After-action reports from Normandy specifically advised tank commanders to avoid direct frontal engagements with Panthers when possible, but also noted that Panthers frequently withdrew or broke down during extended engagements. Soviet tankers were told, don't try to outfight a Panther, outmaneuver it, make it move. Movement kills Panthers better than your gun does. And they were right. By late 1944, the Panther's reputation was so tarnished that some German commanders actually requested older Panzer IVs instead, because at least those tanks were reliable. Today, the surviving Panthers in museums around the world tell the story of this contradiction. They're beautiful machines, sleek, powerful-looking, intimidating, even when silent and static. Museum placards often describe them as one of the finest tanks of World War II, and that's technically true. But what the placards usually don't mention is that most of these museum Panthers never fired a shot in anger. They broke down before they ever saw combat. There's a Panther at the Bovington Tank Museum in England that was recovered from a training ground in Germany. It has 47 kilometers on its odometer. 47 kilometers. And its final drive had already failed. That tank never even made it out of training, and it sits in a museum as a testament to engineering excellence. The legacy of the Panther extends into modern military thinking. When engineers design tanks today or aircraft, or ships, or any complex military system, the Panther is often mentioned as the cautionary example. Don't over-engineer. Don't optimize beyond your production capacity. Don't design for perfection when you need reliability. Build in margins of error. Except that crude and functional beats elegant and broken. The American M1 Abrams, probably the most successful tank design of the last 50 years, embodies these lessons. It's not the most sophisticated tank in the world. Its turbine engine is fuel-hungry and not particularly efficient, but it's reliable. It can be maintained in the field. It works, and in combat, that's all that matters. So what's the final answer to our mystery? Why did Germany keep building Panthers with a fatal flaw they knew about and knew how to fix? Because fixing it would have required accepting an uncomfortable truth, that their pursuit of perfection was actually making their tanks worse. It would have required admitting that sometimes simpler is better, that sometimes you need to take a step backward to move forward. And Nazi Germany in 1943 was not an organization capable of accepting uncomfortable truths. The entire regime was built on the fantasy of German superiority, of German engineering genius, of inevitable victory. Admitting that your finest tank was fundamentally flawed would crack that fantasy, so they didn't admit it. They just kept building Panthers and sending them to the front and watching them break down and pretending it was somehow acceptable. The Panther didn't destroy itself because of bad engineering. The engineering was brilliant. The Panther destroyed itself because brilliant engineering, applied inflexibly in a context that demanded something else entirely, becomes a liability. The machine was perfect. The situation was not, and the machine couldn't adapt. That's the real mystery of the Panther's final drive. Not the technical failure that's easy to explain. The mystery is why intelligent people kept repeating the same mistake for 2 years, even as the evidence mounted that they were wrong. And the answer to that mystery is more human than mechanical. Pride, politics, and the inability to admit error destroyed more Panthers than any Allied weapon ever did. The perfect machine destroyed itself. And the lesson echoes through history. Perfection that can't survive reality isn't perfect at all. So the next time you hear someone describe the Panther as the greatest tank of World War II, you'll know the full story. Yes, it was technologically impressive. Yes, it was feared on the battlefield. But it was also a mechanical nightmare that spent more time in repair depots than in combat. Brought down by a component the size of your hand that German engineers knew was inadequate from the very beginning. The Panther's final drive is a reminder that in engineering, as in life, there's no such thing as perfection. There's only trade-offs. And the Germans chose elegance over reliability, sophistication over simplicity, and theoretical performance over practical function. It cost them thousands of tanks, countless battles, and possibly, though the war was likely unwinnable anyway, any chance they had of prolonging the conflict. Sometimes the perfect machine is the one that just works, not the one that could work. Under ideal conditions, if everything goes right, the Panther taught us that lesson at tremendous cost. Let's hope we remember it. Thanks for watching. If you found this deep dive into the Panther's fatal flaw interesting, let me know what other engineering mysteries from history you'd like to see explored. And remember, perfect is the enemy of good. The Panther proved it.